Hey y'all, it's Mumu, and I'm back with science today. Today we will solve a question from Problems in General Physics by IE Irodov. Today the question we are solving is question number 140 from I think the first chapter. So please observe the question once before I start solving. Okay, I will start. So I've already drawn the diagrams to save time. So this is actually the initial diagram, figure 1, where you can see this string is still attached and has not been burned. And we know from the question that the spring constant of the spring here is 5 mg by L naught. And L naught here is given as 50 cm, which is equal to half a meter. So I can directly write the spring constant as 10 mg. Now, when we burn the string, it is said that there will be a moment where block A will lift off. So I'm drawing the next diagram at the critical moment right before this block takes off from the surface. So as you can see, since this entire system will go down, the amount of x this string has gone down will be the amount of x this block has gone horizontally. Why? Because the string is inextensible. So whatever this will go down, this will go horizontally. Now the spring will obviously extend because of that. So I've taken this length as L dash. Now I'm taking L dash is equal to L naught plus Y. So therefore it means Y equals to L dash minus L naught. So Y is the extension in the spring and L dash is the elongated length of the spring in that exact critical moment, while L naught is obviously the initial length. So let's get solving. We will draw the FBD of block A in this critical moment. Okay, so I hope you can see this well. So obviously Mg will be acting on the block. Now I will write that there's a normal force acting, even though I would take it as 0 in that moment, but it's still a good habit to write it. And now in this direction, Ky will act. And why Ky? Because y is the extension in the spring, and as we know, spring force equals to Kx. And since I have taken this angle as theta by alternate interior angles, it means that this will be theta too. And since I'm dealing in the y-axis, I will not take any force components in the x-axis, as I don't think it's that necessary, but you can draw if you want. So from the figure, we can write that n plus ky cos theta is equal to mg. And like I told, at the critical moment, right before touch off, this n becomes 0. Now we know from here that k equals to 10 mg, so 10 mg into y cos theta is equal to mg. Now mg will get cancelled off from both sides, as it's definitely a non-zero quantity. So we at the end get that y cos theta is equal to 1 by 10. Now from the figure we see that this is actually kind of a right angle triangle. Well, it is a right angle triangle. So if we use trigonometry, we can write that L dash cos theta is equal to L naught, which we know is half. And now we also know that L dash is equal to L naught plus Y. So L naught plus Y cos theta is equal to half. Meaning L naught cos theta plus Y cos theta is equal to half. So this therefore means that cos theta by 2 is equal to half minus 1 by 10, and I've put 1 by 10 directly because we know that y cos theta is 1 by 10, which is equal to 4 by 10. Therefore cos theta is equal to 4 by 5. Now if we use basic trigonometry, which I hope you know, this we know is half or 4 by 8. So L dash becomes 5 by 8. And because of trigonometry again, this becomes 3 by 8. This is basically a standard 3-4-5 ratioed right angle triangle. And from here, we get to know that y equals to 5 by 8 minus half, which is equal to 1 by 8 meters. Please write the units. I've actually forgotten a lot of them. But since this is a rough work, I'm not writing, but in exam, please write or else you'll get confused or your marks will get cut. So, I'm sorry. Just observe this page for once before I will write the WET equation, which is the work energy theorem equation, which states that work done by all the forces in a system is equal to change in K. And these are all the values we know. So this means this block has also gone down 3 by 8 meters. And this is mg. So for both the blocks, the velocity in that moment will be the same because it's attached by the same string. So final K, where I'm taking the velocity is v, the touch-off velocity. So half mv square plus half mv square. This is the final K minus 0 plus 0. This is 0 plus 0 because obviously the blocks weren't moving initially. And now the work done by gravity over here is positive as this block is also going down and gravity is obviously acting downwards. Okay, why? So mg is the force multiplied by 3 by 8, the amount of distance it has gone down. And now spring work done will obviously be negative because if you do the cos theta, it becomes negative, as work done is F dot S, meaning the dot product of force vector and displacement vector. So I will directly put the negative sign here, half K, and it is extended by y, so y square. And now we write that mv squared is equal to 3 mg by 8 minus half, and k we know is 10 mg, so 10 mg, and y we know is 1 by 8, so I will directly write 1 by 64. This and this cancels off and becomes 5, and m from LHS and RHS gets cancelled off as it's common in all the terms of the equation. Next, v square is equal to 3g by 8 minus 5 by 64g, which is equal to 19g by 64. Now we can write that v squared is equal to 19g by 32 into half, and half we know is L naught. So 19g L naught by 32 is v squared. Therefore, v is equal to square root of 19g L naught by 32. And this, my fellow audience, is the answer. I hope you have enjoyed this explanation and have understood it thoroughly, and I hope to be back with another video. Thank you.